Alright, going to cover Chapter 10 today. Chapter 10 is all about planning and cabling a network. We're going to get into some topics about choosing the correct devices, whether you should choose switches or hubs, what routers are used for, and the correct type of cables. It also gets into how you should break down your networks for the addressing scheme with subnetting. I'm not going to talk a whole lot about that because we've already gone through the subnetting, but that's also mentioned in this chapter. So it's going to give you a brief overview, hopefully help you answer some of the questions on the study guide, and get you ready for the online Cisco test. This first slide here is talking about routers. Now routers can be used either as a LAN device or a WAN device. One thing that routers do that no other device can do is break up broadcasts. They break up broadcast domains. If you remember what a broadcast is when we want to send to every computer on the network. So let's say over here, this left-hand picture, this top computer wanted to send to every other computer in that network. What it would do is it would send out a broadcast. That broadcast would come down to the switch and get flooded out. That broadcast would come to the router, and that router would stop that broadcast. That's the only device that can stop that broadcast. If this router was not here, that broadcast would continue on to that switch. That switch would also flood it to every port. That's the only thing that switches ever flood to every port is a broadcast. Well, the reason why we might want to break up that broadcast into smaller domains is if we had a large topology. Think about BSC's topology. Let's say that one computer in the Jack Science Center wanted to send a broadcast out the network. Well, that would cover every single building on BSC's campuses. That's a lot of labs, a lot of staff computers, a lot of faculty computers for that broadcast to go through. So what you might want to do is place a router in between the floors of a location or just in between the locations, any way that you can break those up to help slow down or to help stop some of those broadcasts from being sent over the whole entire network. That's the situation like you have on this picture over here. Two different locations. Let's say this bottom location is the Jack Science Center. The top location, Warner Hall. In between those, place a router. We have two separate broadcast domains. This also breaks up collision domains, just like our switches, bridges, and routers did that we learned about in the last chapter. This also break up our broadcast domains. Now we have two broadcasts, a little bit more efficient. Typically what you're going to see a router used for though is a WAN connection. Internet coming in, a network coming in from a different location has to come into a router so that we can route traffic in between those networks. This slide here gets into the difference between hubs and switches. If money is not an issue, always purchase a switch. Reason being, switches can give you full duplex. We're not going to have any collisions. We have that dedicated bandwidth, basically kind of doubling our throughput because we can send and receive at the same time. Remember, every port on a switch is a collision domain. Hubs, on the other hand, a little bit more economical. In a smaller type of topology, they're going to be just fine. The more computers we add to that hub, though, the more collisions are going to happen and the less efficient the performance is going to be on our network. So again, if money is not an issue, go ahead and buy a switch. The benefits are going to outweigh the cost probably. If you're ever asked to buy a device for your network, there's going to be some different things that are going to be factored in. The biggest one's cost. What type of ports do you need? The speed of these ports. Is it expandable, or does it just have cards in there that can't be expanded? They're fixed. How manageable is it? How easy is it? What type of features does it have? By far and away, your biggest one's going to be cost. Your boss comes to you and wants you to buy a new switch. He probably has a budget worked out, but you have to find a switch that's going to fit that budget. Again, if money wasn't an issue, you just go buy whatever switch you want with all fiber ports, run all fiber cable, things like that. But there are going to be costs associated. Some things that you want to consider: do you want just one large central switch like we have over here? If you do that, that large central switch is going to be pretty expensive. It's going to have a lot of ports. It's going to have some horsepower because it has a lot of different packets that's going to have to process coming in and out of that central switch. Redundancy. Redundancy is nice but also expensive because we're going to have double the components that we would normally have. If a switch fails, the other switch would be able to kick in automatically and our network would not go down. Downfall of that, you have to purchase more switches because if one fails, there has to be another one to kick in. What you're probably going to see most often is you'll see multiple switches, probably mid to low grade type of switches that are going to be plugged into a central switch. And a lot of times in between these switches, you'll have fiber optic type of cable. This is kind of what BSC has set up. If you ever want to get in here and I can show you one of the cabling closets and how this is set up. Definitely a lot easier to probably understand if you actually see it with your own eyes. But that's kind of what they have set up here. Some other things to consider, and also something that will definitely play with the cost, is the ports that you have. If you have just 10-100 ports or gigabit ports, the gigabit ports are going to be a lot more expensive than the 10-100s. They have come down in price, but they're still a lot more spending than just 100 megabits per second. Also, is it just the RJ45 ports for unshielded twisted pair cable, or does it have fiber optic ports for ST and SC connectors? If we're talking fiber optic ports, that's going to be a lot more expensive. Again, if money wasn't an issue, you could buy a switch that had all fiber optic ports, plug those fiber optic ports into your computers, things like that. Routers, it's definitely going to be a lot faster but a lot more expensive. So the more ports that you have, the speed of those ports, and the type of ports that you have definitely come into play when you choose which type of switch you're going to buy. Factors to consider when choosing a router is expandability. Does it have cards that you can add in to that router? Or is it just those fixed cards in there? What type of media does it accept? Serial ports, fiber optic, RJ45s for your LANs, your Cat5 type of cable, some operating system features. Does it have quality of service? Does it provide voice over IP? How secure is it? Any one of those features, expandability, the type of media, and some operating features are definitely going to factor in to what type of router you should choose and how much it's going to cost. A lot of times if you know what you need, you can call up a Cisco vendor, say, hey, I have 2 T1 lines coming into my company. I have one fast Ethernet port that I'm going to need and one fiber optic, and they'll hook you up with the right type of router. So it kind of takes some of the guesswork out of it. This slide here gets into the different types of cabling that's going to use. Talk about backbone cabling, horizontal cabling, and patch cabling. Typically what's going to be used for your backbone cabling is your fiber optic. Your horizontal cabling and your patch cabling, that's probably going to be your category 5 or your unshielded twisted pair cable. If you read through the left hand side here, it will give you an explanation about what the horizontal cabling is, the patch cabling. You're going to have to decide which type of media that you're going to use in your network. 3 different types: fiber, unshielded twisted pair, and wireless. Wireless is probably the easiest to set up. It is still kind of considered a little bit less secure, although that's becoming a lot better. The speeds aren't quite there though. Speeds are a little bit slower than our unshielded twisted pair. Unshielded twisted pair is great. It's easy to install, a little bit harder than wireless because I'm going to have to do cable runs and things. But the speeds are great, it's cheap, easy to install. The downfall of the UTP is that it is susceptible to electromagnetic interference and radio or an RFI. So keep that in mind if you have to run through a ceiling where there's fluorescent cables or into a room like a boiler room where there's motors and things like that. you may want to use fiber optic in that scenario instead, because fiber optic is not susceptible to that EMI or RFI. Fiber optic is by far and away the fastest. It can go greater distances, but it is more expensive and it is harder to work with. Essentially what's inside of a fiber optic cable is a glass. It's a piece of glass that your light travels over, and that's very delicate, so a little bit harder to work with. When cabling out your networks, keep into mind the length. The maximum length that unshielded twisted pair can go is 100 meters. What happens is called attenuation. Attenuation is the degradation of the signal as it goes along its path. So when it leaves the source going towards its destination, that signal degrades as it goes along the line. Well, after 100 meters, that signal is going to be too degraded, and that receiving host is not going to be able to pick up on that. So with an unshielded twisted pair, 100 meters. If I need to go farther than that, I can use fiber optic. The multi-mode fiber here, 400 meters. There's also another one here that can go 2 kilometers. Our single mode fiber is going to be the farthest, 10 kilometers we have here. Multi-mode fiber is typically used for bends going around corners, things like that. It has a bigger core, so it can go around those corners. It's going to be less in speed though, and less distance because of that. Single mode fiber is our fastest, goes the farthest, but it has to be kept really straight. It has a smaller type of core. Typically for that single mode fiber, we're using a laser to send our light pulses, whereas the multi-mode, I'm just using LED. So another reason why the single mode can go farther, because of the laser light. Ease of installation, like I said, fiber optic a little bit harder to work with, harder to install. It is more expensive. You're probably going to have some type of specialized skill if you need to splice those fiber optic cables together. Whereas UTP, pretty simple to install. Your hardest part's going to be running the cables through the walls and through the ceilings and things. Making these connections. There are basically 2 standards for a UTP cable when we pin them out. If you open up a UTP cable, there's different colored wires inside. And we have to have some type of standard to pin these out. Well, there's 568A standard and 568B standard, and you can see the color codings behind this. For a straight through cable, we're either going to use 568A or 568B, and both sides are going to be the same. So both sides are either going to be 568A or both sides are going to be 568B. For a straight through cable, or excuse me, for a crossover cable, one side would be 568A and the other side would be 568B. Again, the rule of thumb for crossover cable is like device to like device. Switch to switch, crossover. Switch to hub, crossover. Hub to hub, crossover. PC to PC, crossover. Really the only exception behind the rule is a PC to a router. If I plug my PC's network card into a router's LAN interface, that is going to be a crossover. The straight through cable is unlike device to unlike device. So PC to a switch, PC to a hub, hub to router, switch to router. Those are unlike devices. Those use the straight through cables. Another concept that's brought up in these slides here is the MDI, MDX. What the MDI, MDIX selection will allow you to do is on some routers and some switches, there will be a port that's labeled MDI, MDIX. And what this will allow you to do is it will take a straight through cable and essentially convert it to a crossover cable. For example, let's say that you have 2 switches that need to be connected together. Well, 2 switches together would be a crossover. Well, let's say you don't have a crossover cable available to you. So what you could do is plug one end into one switch, plug the other end of that straight through cable into the MDI/MDIX port, hit that button, and then that port will do the crossover for you. Again, essentially just takes that straight through cable and converts it to a crossover cable. This slide here is a great way to quiz yourself on which type of cables you should use. You roll over the straight through part and it will show you which connections would use a straight through cable: router to switch, switch to PC, hub to PC. Which ones use a crossover cable? Hover over the crossover, router to router, switch to switch, switch to hubs. Again, a great way to quiz yourself on which type of cable should be used. Making a WAN connection, this is going to be specific to your router. When you buy a router, again, you have to determine which type of connections are you using. Are you using a smart serial? Are you using a V35? Which type of cable and which type of connector do I need? When you get into the labs over here for semesters 2, 3, and 4, you'll see all these different types of connectors that the routers have. We have all these different types of cables. Important concept here, DCE and DTE. What DTE is data terminal equipment. And basically what that is the end user's device. It's the device that you own. The DCE typically is the device that you're renting from your service provider. So if you're renting a cable modem from Mid-Continent, the DCE device would be that cable modem. It's going to provide the clocking, it's going to provide the signal and the speeds into your router, which would be the DTE, the piece of equipment that you own. If you're using a T1 line, T1 lines come into a CSU DSU. Well, that CSU DSU you would probably have to rent from your service provider. So that CSU DSU then would be the DCE. The DTE then would be your first piece of equipment that you own, typically the router. Well, in a lab environment, in our labs over here, we don't have a T1 line coming in between our routers. We don't have cable modem coming in. We don't have that device that we're renting from a service provider. So what we do is we take a DCE DTE type of cable, a crossover cable, it's kind of called, and we're just going to decide that one router is going to be the DCE and the other router will be the DTE. So we're just kind of simulating that DCE connection. We're going to say, okay, this router over here, you're going to provide the clocking, so you're going to be the DCE side. So we'd look at that cable, find the DCE side, and plug it in to that router. And this will make a little bit more sense when you actually do it in the labs and you see it hands-on. You can do it in Packet Tracer, and that's another great way to get some hands-on experience with this. Here's that Packet Tracer lab on how to do it. The middle part of this chapter gets into how we're going to address our network. Again, either you can determine how many locations you have, or you can determine how many hosts that you need. I'm not going to get into this because, like I said, we've gone through the subnetting before. So maybe you just want to read through it, skim through it, kind of get an idea of what they're talking about. Should be nothing too new for you. The last thing that I want to mention here is the interfaces that you're going to see on the back of a router. We have the serial interfaces that we kind of talked a little bit about. Those are going to be our WAN connections coming in, whether it be a T1 line, cable modem, something like that. We would probably plug that into our serial interface. Our console interface, what that is used for is to initially configure a router or to initially configure a switch. Anytime we need to initially configure a device, the console cable is the only way that we can do this. And I'll explain this a little bit more in the next slide here. Your fast Ethernet interfaces, these are typically going to be used for your LAN type of connections. We would plug a straight through cable into our fast Ethernet, then go into a switch, and then all the other computers would plug into that switch. So now we have all connectivity with that router. The auxiliary interface, what this can be used for is, let's say that you administer a router in Fargo and you're here in Bismarck. Well, what you can do is hook up a modem to that router, you dial into that modem, and now we're connecting to our router over the phone line with that modem into the auxiliary interface. Alright, so we want to initially configure a router or a switch. Again, what we do is we plug a rollover cable into the console port of that device. The other end of that cable will get plugged into our COM port of the computer we want to configure it with. Most of the time, you can't just plug that cable into the COM port. So you have to have what's called the DB9 connector. A lot of times when you buy a Cisco device, it will come with this rollover cable already assembled, and that DB9 will already be connected onto one end. But if it's not, you have to have that DB9 connector. What a rollover cable looks like is the pins are 1 through 8 on one side and then the complete opposite on the other side, 8 through 1. So 1 through 8 on one side and 8 through 1 on the other side. That is what a rollover cable is used for. Alright, that's all I wanted to mention for Chapter 10. Again, if you have any questions, please let me know. If you want to see some of this stuff hands-on, definitely let me know that too, and I can get you into those labs. Thanks.